So today we have lesson 10 and 14 combined. They're both about outliers, so might as well talk about them now together. We never change like the names of the lessons, so that's why sometimes they're out of order. That's why sometimes like we skip them, like we did lesson 6. We did not do a lesson 7, 8, but then we moved on to like 9 and now 10 and 14. This week is like the last full week of instruction. Hopefully.
Miss Medina. Yes. Okay. Bye. Okay. Anyway, this week is the last full week of instruction because next week you are taking your Unit 1 test. So you really do have like the weekend to prepare, make sure your binder's ready, all that stuff. Next week we're reviewing like Monday, Tuesday, and then you are taking your test Wednesday. Notice like if you look to the board over here on the right, I also have a day scheduled for retaking the Unit 1 test. That does not mean that you just bomb it the first time because you know that we're retaking it. Because really, I don't have to give you like another retake after that. Just saying. So that I do in class so that I could avoid having like a million people in tutoring at one time trying to do retakes. And that way I can have more people in tutoring for actual like help with stuff. So that is coming up next week. Make sure that you're ready and prepared. All right. The goal for today I mentioned is about outliers. So using the shape of distribution to compare the mean and median, to find outliers, investigate their source, and figure out what to do with them. And you can tell how an outlier will impact mean, median, IQR, and standard deviation. Real quick, can someone explain to me what an outlier is? What was that? By itself compared to what? All the other data. So it would be a number that is either higher or lower significantly than the rest of the data. You could kind of look at data and assume, but the only way to know for sure is with this formula that I'll give you in the lesson. So those are great test questions. Sometimes it's hard to tell if it's actually an outlier or not. So that's what we're going to look at today. I'm recording right now. It'll be linked in the slides. The practice is actually 2 separate practices, but it's only like 4 or 5 questions each. So they're just separate because they're technically different lessons, but we're combining them. Let's do them. They're not very long. And then, yeah, I'm not planning to give you a quiz on Monday next week because we're testing that week for Unit 1. Anytime a unit test comes around, so does binder check, and so does the deadline for everything from that unit. So if you have missing work that's been piling up, you basically have until Tuesday next week to turn it in without penalty. You'll get full credit still. Another thing I want to remind you, I highly encourage you, like if you've not been doing well on your quizzes, that you go back and review your quizzes, do test corrections, maybe come in and do retakes, but whatever score you get on your Unit 1 test, if you have any quizzes that are lower, I will match that score. So say you've been failing your quizzes, but managed to get an 80% on the Unit 1 test. I'll give you an 80% on your quizzes. And same if you got like a 60. Well, then if you have any quizzes below a 60, I'll give you a 60. So we'll really try to like go back and see what you're doing wrong. Any questions on any of that? Okay. So the warm-up, hopefully it's done by now. We have plenty of time. You are supposed to use technology to find the mean and median. You could also do it by hand. Like yesterday, I had some people forget how to use the graphing technology. That's why we still teach you by hand. When you ask me how to use your calculator during the test, I'm actually not supposed to help you. because that wouldn't happen on your state test. You just have to tell you to do your best. So someone volunteer. Tell me what you got for the mean of this data. Benji? All right, and then the median, over here. 10 as well. Anyone get something different? Okay, hopefully not. If you did, just check to make sure there was 18 data points up here. So when you're putting it in the calculator, it should say 18 element list. And then you can just find your mean and median that way, or do it by still should be 10 and 10. Now, if you haven't done this already, we'll kind of do it together. For the next part, we're gonna add 2 additional values as described. So for the first part, part A, we're gonna add 2 values that are greater than 14. What are some numbers greater than 14? All right, and so you could, as long as it's greater than 14, you could have picked other numbers. Could have been 14.1, could have been 30. All right, just said it has to be greater than 14. But we can use this if you haven't written them down already. And now for B, we're gonna add 2 values that are less than 6. So what are some numbers less than 6? And 2. Okay, I heard 3 and 2 first. So if you already have numbers smaller than 6, that's fine. You don't have to change them. You'll see the same trends when you do them. And then next we have add a value that's greater than 14 and then a value that's less than 6. So, yes.
Those are what is, when we add the value, like, we keep other values.
So that's a good question. You change it each time.
Honestly,
So like when you put data in for A, you should have 20 values total. And then B, it should be 20 values. You're changing the ones that you added. Does that make sense?
Yeah.
Okay. So good question. So then now for part C, what's a number that's greater than 14? And then a number that's less than 6. All right, and lastly, you would add in 50 and 100, making it big. So if you haven't done that yet, maybe get your Desmos out. That's the best way to see it, in my opinion. You can still learn to use your graphing calculator, but do it now with those additional values. And I'll kind of do it at the same time too, if you don't know how to add it in. But see how the mean and median change. Yes. Right, so on my screen, if you want to look, is what you got for part 1. All right, 18 data points. Now, when we get to part 2, to A, we're adding the 15 and 16, or whatever numbers you picked that are greater than 14. I'm gonna make my life easy and just add it to the beginning, like this, 15, 16, and then I now have 20 data points. See the changes that happened. What happened to the mean from before? It went up, so I'm gonna mark that on my paper. We have an increase in the mean. Do I have an increase or decrease in the median? So there is no change in the median. You could write no change for the median. I'm just gonna put the mean increase, because that was the only change. Now, we're gonna take out those 2 points again. And now we're gonna put in smaller than 6. So we picked 3 and 2. Make sure you don't leave it as a 26. Make sure you put the comma. I should have 20 data points. What happened now? The mean decrease. Any change to the median? No change to the median. And then again, make the change. Now we want for part C, greater than 14, smaller than 6. So we're gonna do 16 and 1. 20 data points and see what happened. What happened to the mean? The mean decreased. And then what happened to the median? Anything? You can just throw the past away. All right, no change to the median. I think in first hour, I forget what numbers we use. Probably 15 and 5. There was no change for either when we did that. But this time there was a change and it was only the mean. Now do the 50 and 100. Karen? Yes. All right, so see what happens when we put the 50 and the 100. What changed? The mean only, and it increased, so put that the mean increased. But again, no change for the median, for any of them. So maybe I'll put on my notes. Kind of off to the side for all of these. Median did not change. Now, discussing your groups briefly, why the mean changed, but not the median. Give me like 30 seconds. Why did the mean change each time? When we added numbers bigger than the rest and smaller than the rest, sometimes both, the mean changed. Why did that? Some values went up, and then when did the mean go down? 5. When we added values that were smaller. So that's to be expected. When we added values that are smaller than the rest of the data, we could expect the mean to go down, because that's like our typical value. I don't know what these could represent, but say again, it's like bulls in a soccer game. If I now add 3 and 2, that means their average is going down. If I add bigger numbers, their average is going up. For this one, we added a number that was bigger than the rest of the data by 2, and then smaller than the rest of the data by like 5. So because it was more of a difference on the lower end, that's why our overall mean decreased. For the last one, when we're adding a 50 and a 100, that's like much bigger than the rest of the data, we could probably tell that the mean would increase without even doing it. Now, why did the median not change for any of them? Yes.
Because you're adding 2 of them or another number on each side.
Okay, whatever, because we're adding a number on each side. Now, we did that on part C, but like for A, B, it was like just one side that we added numbers. Why did the median still not change? Yeah. There were 4 10s in the middle. So the median, will it always not change? No, like it'll change in other data sets, but because this data set has 4 10s in the middle, and I added at most like 2 on each side at different times, it didn't affect my median at all. But it could, it just depends on the data set. So yeah, keep that in mind. When we have data points that are more to the left, more to the right, we might be skewing our data, making it less symmetrical. In those situations, it still might be better to use the median over the mean. Okay, because if I add like a 50 and a 100, and this is supposed to be goals in a soccer game, isn't like 50 and 100 really unusual? Yes, no? It is unusual, right? I've never seen a soccer game with 50 goals, right? So in that case, it might be better to use the median, which is more like what the rest of the data is. Does that make sense? Okay. Now here's what we're gonna do. So don't erase your data in Desmos yet. If you already did, you know, maybe just put it back. But we're gonna go back to where it was 18 data points. So I'm gonna erase the 50 and the 100. It might be best to see the data distribution with a dot plot. So here's my dot plot of the data without any like additional values. What you guys will do in your groups is you're each gonna have a different distribution. So what are the shapes of distributions that we've talked about before? Skewed. What's some other ones? Bell-shaped, uniform, bimodal, good. Good, that's another one. And I think that's all of them. I think there was just 5. Anyway, at your tables in your baskets, you should see an index card with what your table will be assigned. You're going to change the data to match whatever distribution you're assigned. So like, yeah, my data is currently bell-shaped right now. So if I had bell-shaped, I wouldn't have to do anything. It's already good. But if I had like skewed, I might have to put it to one side. So I would have to adjust my data to match that. Does that make sense? Okay, it's best seen on the dot plot in Desmos. So I encourage you to use that. And then we'll discuss in about 3 minutes. There's at least one other group that had the same model you had, but theirs might look different and still be the same shape. I'm gonna have you identify yourself. So if you had bimodal, raise your hand. Okay, see what other group had bimodal, memorize it. If you had uniform, raise your hand. There should be 2 groups, okay. Skewed right, raise your hand. Skewed left, raise your hand. And is there any that I missed? I think that's it. So share with your group that matched yours what you got. What does your distribution look like? Is it truly what you were assigned, or did they make a mistake? You can get up, show each other, be prepared to talk about it. Of course, there's millions of ways you could have changed your data and it still be right. Here's an example of what it would look like as uniform. I'll show you on Desmos. I'll replace my data with this. This would be a uniform distribution where it looks the same on each data point, something similar to this. Then I'll show you a skewed right if you had skewed right. All right, skewed right, because the void would be on the right. All right, it's kind of opposite of how it's named. The data is more on the left, but the void is on the right for skewed right. Now let's see, skewed left would look something like this. With more of the data on the right side, the void on the left, if it's skewed left. And we didn't do symmetric because it was already symmetric to begin with. Bimodal, let me see how I can make this bimodal. I don't have a good example for it. Maybe this one's actually bimodal, if I remember. All right, this one is an example of bimodal and symmetric. Okay, so something to that effect. Now, another thing you were supposed to do was look at the means and medians each time. Here's an example. It should match the same trend, even though your numbers are probably different. So when it's uniform, the mean and median tend to be the same. And the middle of wherever it is. When it's skewed right, the mean and median are usually different, but the mean is increasing. When it's skewed left, notice our mean decreased from the 10 that it was originally, and the median changed. And then when it's bimodal, the mean and median are still 10, approximately. So questions on that? When our data is skewed, which would be better to use, the mean or the median? What was that? Okay, well, maybe talk about it in your group. The question was, when the data is skewed, what might be a better measure of a typical value, the mean or the median? Talk about it with your group. Sounds good. So if it's skewed, what do you think would be better, the mean or the median? Yes? The median. Because if you have just a few values that are like way bigger than the rest of the data, it'll pull the mean up, but really most of our data is still closer to here, if that makes sense. So know that when data is skewed, the median is preferred over the mean. Questions on that? And we'll kind of see more in a little bit. All right, so moving on from this activity, good practice with the data distribution. Now, you're going to look at that histogram and box plot that is in your notes. So look at the histogram and box plot that is in your notes. These two. All right, one value in this data set is an outlier. Think to yourself, which one is it? Thinking, no talking. I'm telling you, one of these values in this data set, which is average amount of money in thousands of dollars spent on each person in the country for healthcare. That's what it represents. One of the values is an outlier. Think about it, which one that might be, and what its approximate value is. Because can I see the exact value when it's a histogram or a box plot?
Yes.
Maybe if it's on the minimum or maximum.
I thought you could see like the box.
On the histogram, you can't tell what any of the data points are. You can tell what they're between. On the box plot, you can only tell your 5-number summary. But even so, you might have to approximate it based on the number line. It's not exactly on the 1 or the 10. So what value do we think is the outlier? I'll take a volunteer. Over here.
9%.
This part. What value do we approximate it to be? Someone different? Brooklyn? 9.5. About 9.5. Maybe a little more since it's not exactly in the middle of the 9 and 10, but 9.5 could be a good approximation. Now, that represents in thousands of dollars, by the way. But how do you know it's an outlier, potentially? Over here.
Because it's not another value.
Because it's far from the other values. And it's either like a minimum or a maximum. So that is how we can visually guess. This time I told you it's an outlier, so you kind of already know. But there is a rule, and I'll have you write down the rule in a second. But the rule for determining for sure if the value is an outlier is if it is more than 1.5 times the IQR away from either quartile. So think about what that means. What is the formula for IQR? Q3 minus Q1, which on what data display can I tell or at least approximate my Q3 and Q1? On the box plot. Here would be where my Q1 is. Here would be where my Q3 is, approximately. So then what is my Q3 approximately? Is it exactly on the 5? So like a little before that, we could go like 4.9. And then where's the Q1 about? A little bit past the 2, so maybe like 2.1. So if I do the math with a calculator, as you should, you could actually put this whole thing in the calculator. 1.5 parentheses 4.9 minus 2.1. If you break it up and do it at separate times, you just need to know your order of operations. So make sure you do the parentheses before multiplying. All right, but I get 4.2 for that value, 1.5 times the IQR. The rule is that if it is greater than 4.2 in either direction from the quartiles, then it's an outlier. So let's see. 4.2 plus 4.9-ish, so that's about 1, 2, 3, 4.2-ish, about here. Is this value to the right an IQ, not an IQ? Is the value to the right an outlier? Yes, because it went beyond the 1.5 times the IQR. If I check to the left of quartile 1, going 1, 2, 3, 4 approximately, is this value that's over here an outlier? No, because it's not past that 4.2 threshold. Does that make sense? Maybe it'll make more sense with this rule that I'm about to show you. All right, so we know something is an outlier if it is smaller than Q1 minus 1.5 times the IQR, or if it is greater than Q3 plus 1.5 times the IQR. So I would copy this down. This makes more sense to me, in my opinion. But if you're more of a visual person, then you could use this picture. You could copy that in if you want. Where you can visually see 1.5 times the IQR from each of the quartiles. I'm going to try and make that big. But you should copy it down. There's a space for you to copy it. I think that's as big as I can make it. So a data value X is an outlier if X is less than Q1 minus 1.5 times the IQR, or if X is greater than Q3 plus 1.5 times the IQR. So if it's close, like on this box plot, if it's close to, I don't know, 42.5, that little tick mark, I might need to actually test it to see if it's an outlier. Now, if the value I'm testing is like 1,000, obviously that would be an outlier. I probably don't need to do the math for that, but sometimes on the test, it's hard to tell. So that's the only way to know for sure. Questions on that? Okay, I'm gonna direct you in your notes to the part that says origins of outliers. So find where it says origins of outliers, and you're gonna use this to do that problem essentially. I'm gonna switch to that problem here now. So the number of property crimes such as theft reports is collected for 50 colleges in California. Some summary statistics are given. So they already found the mean for you and your 5 number summers. And they also have the data for you. You are going to determine if any of the values are outliers. And then if so, which ones? And I just gave you a formula for how to like truly determine that. So work on this for about 3 minutes, I feel like would be how long you need, but we'll see. We'll start with this problem. Are any of the values outliers? Explain or show me these. Let's see if we can point some that are stuck in the right direction. So if I'm asked which values are the outliers, what are you looking for, like in your data? Like what numbers do you think might be the outliers? Just visually. Yes. Okay, maybe 15. Any others? Over there. 768. Could there be more than one outlier? Could there be more than 2 outliers? Just depends on the data. So if we're testing numbers that are more to the left on the number line, so smaller than the data, what rule do I use? So like if I'm testing that 15, it is an outlier if it's less than what? That's where this comes into play over here. If I'm testing a number that's more to the right on the number line, which one of these do I use? Or yes, the one that is for data that is much smaller than the rest of the data. Because we're comparing it to the Q1. That makes sense? So Q1 minus 1.5 times the IQR. So if it is, then yeah, that would be an outlier. Now it gave you the summary statistics, so you don't have to put this all into Desmos to find what your Q1 is. What's my Q1? 52. All right, minus 1.5 times whatever the IQR is. My summary statistics don't say that the IQR is this number, but you can figure it out because IQR is what minus what? Q3 minus Q1. So I'm just gonna put 260 minus 52. Yeah, I could probably solve that separately, but I like to make my life easier and put it all in the calculator at once. That means all of this. I'm gonna figure out what that number is in the calculator. And then if that number is greater than 15, then yeah, that 15 is an outlier. Does that make sense? So do that. I'll stop it there. I'll let you continue the rest. So see if that 15 is an outlier, or if any of the numbers to the right of the data are also outliers. Give you like 3 more minutes to do that. If you finish doing that early, you think you have your answer, then you can take out your Chromebook and work on the practice while we wait for over. 3 more minutes to see which numbers are outliers and if so, which ones. Is the 15 an outlier? Yes or no? Tell me all at the same time. 1, 2, 3. No, it is not an outlier. Because when I put what I boxed in the red in the calculator, I got negative 260. Is 15 less than negative 260? So this is false, which means that 15 is not an outlier. For it to be an outlier, it has to be less than negative 260. Does that make sense? So none of these numbers are less than that, so there's no outlier, at least on the left side. Are there outliers on the right side of the data? What are they? Yes, the last three numbers are all outliers. It is possible to have more than one. So 593, 699, and 768. And the reason why would be because they are greater than what? Good. What's the exact value actually though? 572. Now, if you're wondering where we got that, I will tell you right now. Since these values are on the right side of the data, closer to Q3 than Q1, we're going to use this formula, where if X is greater than Q3 plus 1.5 times the IQR, then they are outliers. So hold on one second. Q3 is 260, right? We get that from here. Plus 1.5, because it would have to be greater, so we'll change that minus to plus. And then the IQR is Q3 minus Q1, so 260 minus 52. That you put in the calculator, just the right side, like don't put the X greater than, because it probably won't tell you anything in Desmos if you do that. I will tell you in a second. 260 plus 1.5 times 260 minus 52. All right, that's how we get the 572. And then the three numbers at the end, the 593, 699, 768 are all greater than 572. So they are all outliers. Questions, comments, concerns? That's the only way to know for sure if they are. You could guess and you might get it right, but it's not always going to be that easy to guess. Questions, comments, concerns? Okay, so the practice is actually both the 10 practice and the 14 practice. I shortened them so that combined it's like 9 questions total, like your other practices. So that is the task. The lesson 10 practice and the lesson 14 practice. You could get at least a few problems done. So there's like 4 problems and then 5 problems. Really easy. Make sure you don't lose your notes. Binder checks coming soon.